Today's lesson is a little snippet of quadratics. Let's consider the paths created by a bouncing ball, a water fountain, and a suspension bridge. The type of function that models these paths is one of the most useful type of functions that change at a non-constant rate. A quadratic function is a function of the form f of x is equal to ax squared plus bx plus c, where a is not 0, because if a were 0, it would just be a line. The common name for the graphical representation of a quadratic function is a parabola. Attributes of parabolas: if a is greater than 0, it's going to open up like that. If a is less than 0, so if a is negative, the parabola will open down. Every parabola has a maximum or minimum point called the vertex. So if the parabola is opened up, it has a minimum. If the parabola opened down, it has a maximum. Parabolas are symmetrical about a vertical line passing through the vertex called the axis of symmetry. So here would be the axis of symmetry for each of those. And you can see it's the same on each side. Graphing them. To graph a quadratic function, first determine if it's going to go up or down. Find the vertex. To find the vertex, you find the x value of the vertex by using the little function negative b over 2a. And then you find the y value by just plugging in x. Determine the x-intercepts and y-intercepts if they exist to help you graph it. If they don't, you can just pick some numbers. Plot the vertex and intercepts and connect them to make a parabola. So we want to graph this function here. We'll start by finding the vertex. So x is negative b over 2a. b is the number that comes before x. So that's negative 6. And a is the number that comes before x squared. In this case, it's just 1. So we have 6 divided by 2, or 3. So 3 is the x value of the vertex. Then the y value would be equal to f of 3. So we're plugging in 3 for x. 3 squared minus 6 times 3 minus 7. We get negative 16. So the vertex is 3, negative 16. So I'm going to go over here and I'm going to go ahead and graph that. There it is. The next step is to find the x-intercept, or septs. There could be more than one, or there could be none. So, to find the x-intercepts, that's where the graph crosses the x-axis. And where the graph crosses the x-axis, y is always 0. So to find the x-intercept, we let y be 0. So in our equation, we're going to put in 0 for y. And then we solve for x. Now, if you'll remember, this has to be factored. Or we can use the quadratic formula, which we'll go over in a minute. I'm not going to go over in depth how to factor. If you don't remember how to factor, you can always use the quadratic formula, or you can graph this in your calculator or on Desmos. And we'll look at some more about Desmos too. So, ask ourselves what will multiply to give us -7. That'll add to give us -6. -7 and +1. So we set each of these equal to 0. And solve for x. So add 7 to both sides. And then over here subtract 1 from both sides. So your x-intercepts are 7, 0 and -1, 0. And then last, let's find the y-intercept. And where a graph crosses the y-axis, x is always 0. So in our equation, we're going to let x be 0. Plug in 0 for x. This gets us -7. So the y-intercept is 0, -7. Okay? If we were to put the axis of symmetry in here, it would go through the vertex like this. And it means that everything on either side is symmetrical. So we could actually take this point and bring it over here too onto the other side of the axis of symmetry. So it's 3 to the left. If we go 3 to the right, there we go. And that just will help us in graphing it. And so now we graph it as best as we can. Just make sure you curve at the bottom. Don't make it look like a V. It needs to look like a U. The quadratic formula is, if you've got a quadratic function in the form y equals ax squared plus bx plus c, it's -b plus or minus the square root of b squared minus 4ac all over 2a. And yes, there's a little song that goes with that, but I won't sing it to you. You probably don't want me to. Example 2 says, we can borrow from physics that if an object is pointed straight upward at a time t equals 0, from a point y naught, with y sub 0, 0 is y sub 0, we say this little thing is a naught. So from a point y sub 0 feet above the ground, with an initial velocity of v sub 0 feet per second, then its height above the ground after t seconds is given by this formula. H of t would be -16t squared plus v naught t times t plus y naught. Suppose a projectile is fired vertically upward from a height of 400 feet above the ground, with an initial velocity of 750 feet per second. And the first thing we want to do is write a quadratic model for the height in feet above the ground after t seconds. So we're going to use this formula up here. H of t equals -16t squared plus, and we need to plug in for v naught. V naught is the initial velocity. It said 750. And then we plug in for y naught. That's the initial height, 400 feet. And so there is our formula. Done with part A. During what time interval will the projectile be more than 6,000 feet above the ground? That is, when will the height be greater than 6,000 feet? So if we want when the height is greater than 6,000 feet, then one way we could do this is to solve for t, but we're not focusing on the algebra here. We're focusing on the actual concept. So let's look at a graph and look at where we could tell that we're above 6,000 feet. So if we graph this, say in Desmos, and we'll go over that, then we would get this parabola here, and we also graph the line y equals 6,000. And so that shows you where the two are crossing. So the projectile, what was it, is above 6,000 feet from there to there. Okay? Well, we can use Desmos to help us find out where those points are. And so this point is 9.3 6,000. And this point is 37.6 6,000. And so what that means is that we're greater than 6,000 feet between 9.3 seconds and 37.6 seconds. So we could say 9.3 is less than t is less than 37.6, or we can say between 9.3 seconds and 37.6 seconds. And then it asks us, how long will the projectile be in flight? Well, we can look at our graph and determine this. It starts and then it ends, right? So how long will it be in flight? 47.4 seconds. But we want to practice using the quadratic formula here. So if we use the quadratic formula, it's going to give us that same answer. So let's do that for a minute. So we want to see where 16t squared plus 750t plus 400 is equal to 0. When does it start and when does it land back on the ground? So we use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And we start simplifying. So 750 squared is this number. And negative 4 times negative 16 times 400 is this number. And 2 times negative 16 is negative 32. Add those up there. We get 588,100. And if we take the square root, we get approximately 766.877. So we've got two situations here. T could be negative 750 plus 766.877 divided by negative 32. Or t could be negative 750 minus 766.877 divided by negative 32. So this first one gives us negative 0.527, and the second gives us 47.4. Well, we've already said 47.4 is the answer. But why is this one not the answer? Because it's negative. Okay, you can have a negative amount of time. If you look back at the graph, you could see it did start over here on the negative, the parabola, but in the real world, it didn't start in the negative. It started here at 400 feet. Okay, and that wraps up quadratics. Real quick example, a couple examples on quadratics in Desmos. So for example 1, we could check ourselves. We were graphing y equals x squared minus 6x minus 7. I'm going to pull this up again so it'll be blank. And so I could graph this on here, y equals x squared. You use the little hat above the 6. So shift 6 and then 2 minus 6x minus 7. And so there is the graph that we graphed in example 1. And you could find the vertex down here. You just click on it and it shows you what the vertex is. It shows you the y-intercept and the x-intercepts. And you can click anywhere along here to find additional points if you need them. Okay, let's look at example 2. So that one we said was y equals, and I'm plugging in y for h of t and x for t, of course, because it won't take the h and the t. So minus 16x squared plus 750x plus 400. And we can't see much on here, so we need to change our window. So I can zoom way out, and you can see it. It just looks like a line there. So we need to change our viewing window quite a bit. Let's see. Let's just do 0 to 100 for the x, and we can always change it if it's not big enough or if it's too much. And then that looks pretty good from there. So there is our parabola for example 2. And we also graphed y equals 6,000. And what we can do now is we can find those points where it intersects very easily just by clicking on the intersection. There is the first one, 9.3, and the second one, 37.55, or we wrote 37.6. So it's really easy to find those intersection points on Desmos. We can also find that x-intercept down here just by clicking, 47.4 seconds. Okay, so again, Desmos is a very useful tool. You are more than welcome to use it rather than doing things by hand. In fact, I encourage it. It's a free tool that you can use at any point you like.